or otherwise spherical mirrors with multiple choice questions. So fed up with problems, no? Numerical problems we have done it a lot. So let us little bit go with the theory, okay, theory bit, and let us see how the questioning will be. Okay, right. So if we consider a few bits, so let me have this border. Okay, border is there. This I can rub, I think. Then here, can I fill here? No problem. So this is my border, right? So right, students, so this is our topic today, right? Okay. So before that, what I do is I'll write some choices here itself. So assertion, reason type. Okay. So we will have assertion and the reason type. So before that itself, I will write. So these choices here. Okay. Both A and R are true. First one is both A and R are true, and R is the correct explanation of A, and R is the correct explanation of A. Okay. Then second one, both A and R are true, and R is not the correct explanation of A. Okay. Next. So third one, are you able to see this? Right. Okay. Then third one is A is true and R is false. A is true and R is false. And then here only I will write fourth one, that is A is false, R is true. A is false and R is true. Then fifth one is also there. Fifth one. Okay. See, don't confuse. Fourth I have written here. 4. This is 4. This is 4. Okay. Fifth one. Both A and R are false. So both A and R are false. So this you have to remember. Then let us go with the first question. Okay. So first I'll read out the question. Then I'll write it. Then we can discuss. Okay. So here, first question what we have is assertion. The mirrors used in the searchlights are parabolic and not concave spherical. Reason, in the concave spherical mirror, the image formed is always virtual. Okay, I'll write it on the board so that you can have a better idea. Okay, right. So you can make a thin line here. So the first question, what we have in the theory, because we have done a lot of numerical problems, that's why I am going with the theory. I don't want to make you still bore by writing all the numerical problems. Okay, so you can go with the question, right? Then let me just use okay, assertion, right? Assertion. Assertion. The mirrors used in searchlights. Searchlights means torchlights or even some big lights. Okay, searchlight. Yes, searchlight or parabolic, not concave spherical. And not concave spherical. So this is assertion. So let us see the reason for this. The reason is here. In a concave spherical mirror, the image formed is always equal. In a concave spherical mirror, the image formed is always what is given here is always virtual. So we'll have a bracket for this, small bracket, and then go with the second question. And in the last, we'll discuss all the questions. Okay. For observing traffic at our back, we prefer to use a convention. For observing traffic at our back. Okay. For observing traffic at our back, we prefer to use a convex. Prefer to use a convex mirror. Then reason. So this is okay. Assertion. Let us have reason for this. So here, what is the reason given is convex mirror has a much larger field of view. A convex mirror has a much larger field of view. Much larger field of view than a plane mirror, not a concave, than a plane mirror or a concave mirror. So this is our bit number 2. Then coming to the third question, assertion. Okay, assertion. The size of the mirror affects the nature of the image. Okay. The size of the mirror affect the nature of the image. The nature of the image. Okay. Then reason. So reason here, what do we have is small mirrors always form a virtual image. small mirror always form a virtual image. Virtual image. So this is the reason. Then coming to the fourth question, assertion. So what do we have is assertion. A concave mirror of focal length maybe medium of in air is used in a medium of Ri, refractive index 2. A medium of Ri2, refractive index 2. Okay. Refractive index 2. Okay. Refractive index 2. Then the focal length of mirror in medium becomes double. Then the focal length of mirror in medium becomes double of mirror in medium become double. Then reason for this. What is the reason? Let us see the reason. The nature of curvature of a mirror is the nature of curvature of a mirror is the nature of the radius of this is the radius of curvature. The radius of curvature. Okay. The radius of curvature of the mirror is double of the focal length. Double of the focal length. Okay. Next student, so this is what we have, right? So the mirrors used in searchlights. Okay, if you see here, right. So I hope it is visible to you all. Okay. So I am reading it the question one by one once again. So here totally we have 1, okay, 2, 3, 4, and 5 options to choose the correct answer among the statements, assertion and reason. Okay. So let us see this. The mirrors used in searchlights are parabolic. You know the shape of parabola. Okay. What is parabola? This is parabola. Suppose this is parabola. Suppose we draw like this on a curved line, then it is a parabola. In maths, you would have got it. Okay. So parabolic mirrors means curved mirrors or spherical mirrors only. Okay. So here, what is given here? So the mirrors used in searchlights are parabolic and not concave spherical, or simply not a concave. That is what is okay. It is a assertion. Then what is the reason here? In a concave spherical mirror, the image formed is always virtual. Okay, just first let us see the assertion. Mirrors used in searchlight. Suppose if you see the mirrors used in searchlight, they are concave only. Okay, so that they produce okay huge beam or the very wide beam of light. Okay, so they are okay parabolic. Okay, lights are parabolic and not concave. He is saying okay, not a concave. He is saying, and the reason if you see in a concave spherical mirror, the image formed is always virtual. See, generally, what is the image we get in a concave mirror? It is almost real, but only in one case it is virtual. That means when the object, when it is placed between the pole and focus, right? So when the object is placed between pole and focus, only a concave mirror will form virtual image. But here what is given? Always. See, in a concave spherical mirror, the image formed is always virtual. So always virtual means it is not correct. So reason is not correct. So then coming to the first one, assertion. Okay. So the answer for this is 3 I am writing. So that means A is true and R is false. Okay. Okay. If you are not able to observe, see here. It is clearly it is indicating that it is false. Okay. So for the first one, the answer is 3. Okay. Right. So it is very clear. Very clear. Right. So the mirrors that are used in the searchlights are parabolic. So parabolic means enough. Okay. So whether it is convex or concave. Right. And not a concave means almost the mirrors that are used in searchlights, they are convex in shape. So that I will explain afterwards. Then second question, if you come, if you see, for observing traffic at our back, we prefer to use a convex mirror. Okay. So this we have discussed already while discussion. That means while discussing the mirror. So the traffic mirror, that means RVM we will say. What is that? RVM. RVM means what? Rear view mirror. Rear view mirror. Okay. Even this also we have discussed while discussing the lesson. So that means what kind of mirror are used or is used to observe the traffic in the behind or traffic behind us. That is convex only. Okay, for observing the traffic at our back, we prefer to use a convex mirror. Then reason, let us see the reason here. A convex mirror has a much larger field of view. Okay, what is this word field of view? So this is a new word to you. Okay, let me explain what is meant by field of view. Okay, so for that I am rubbing this question. So field of view of a lens or a mirror mostly, okay, means what is the actual meaning. Let us see. So for how much of area we can observe, okay, the area which we can observe with the help of that particular mirror is called field of view or field view of that mirror. Okay, concept of field of view, field of view. Okay, so suppose we take a concave mirror like this. So it can form, see this, let us see the tip. See, so you can see the tip. So this much. So what is the maximum angle? See, this much. So this is the maximum angle. Okay, I little bit make it clear for you. Otherwise, okay, I'll draw like this better. Suppose a concave mirror. Let me take concave mirror first. Okay. So in the horizontal axis, suppose This is the concave mirror. Okay, concave mirror, and this mirror can show the objects that are within this much of area. Within this much of area. Okay. Now this one, see, suppose if you are having a, if you draw a line like this, and now if you measure this angle, okay, so you can have this angle. So this total angle, okay. So this is the field view, or the total area which we can see with the help of what? With the help of a concave mirror. Concave mirror. Are you able to see this? Are you able to see this? Okay. So the tip, that means just if you extend the tips of both the sides of the mirror, okay, and you imagine two lines, or no need to imagine. So just from the two tips, the area lying between the imaginary lines of, okay, the area lying between the imaginary lines of a concave mirror. So whatever the area, suppose if it is like this, okay, if it is like this, so here this much, and here this much. So from this much to this much, only this is the area. So this area which we can see, or the area which a concave mirror can show the object if it is placed in between. Okay, it is called its field of view, or simply to say the area of view, the area of view which a spherical mirror means both convex and concave here. A spherical mirror can cover, or if you are keeping an object in a particular area, okay, so suppose if you keep an object here, it cannot show because its field of view is not in that part. Suppose if I keep the object here, this one can't show. Even if I keep it very down, so that also it cannot show. So within its area only, if an object is placed, then only it will be able to show that object. Okay. So this area where, or this area within which the object can be seen with the help of a mirror, the area within which the object can be seen with the help of a spherical mirror or even a plane mirror, we call it as its what? Field of view, or simply field view. Okay. Now let us see for a convex mirror. Convex mirror. So this you would have understood now. So then, okay, concept of field of view. So I'll draw it once again. Both you can see side by side, and you can judge which mirror can show more area. Which mirror can show more area. Okay, this is concave. This is just I am highlighting. Okay. Okay, field of view. Field of view. This is the field of view for a concave mirror. Concave mirror. And then let me draw the convex mirror. Okay, convex mirror, right. Okay, the same. Here also we'll take the two tips. Okay, now you see this much. So it can show up to this much. Okay, see here. Now I am drawing this. Okay, right. So this is the field of view. This is the field of view. Okay, convex mirror. So this is, what is this? Convex mirror. So this is convex mirror. So are you seeing? So if you are able to observe this, okay. So this is the concave mirror, and this is the field of view of concave mirror. And coming to the convex mirror, field of view of convex mirror. Just you can imagine. See how much it is able to show. Is it greater than this one or not? Is the field of view of convex mirror greater than that of concave mirror or not? Yes, surely it is greater. So that means among this, that means anywhere in this field of view, of this convex mirror, if an object is present, then it will be able to show us. So here, just you imagine this one like this. So when you are keeping it in a vehicle, okay, I have drawn here like this. So just you imagine it like this. So lot of area it is covering. The field of view of concave mirror is comparatively greater than that of field of view of convex mirror. Okay, the field of view of convex mirror is comparatively much greater than that of field of view of concave mirror. Okay, students. So now you understood what is the meaning of field of view. Okay, now we will come to the question now. See, for observing the traffic at our back, we prefer to use a convex mirror. Okay, so this is the assertion. Then reason, what do we have? A convex mirror has a much larger field of view than a plane mirror or a concave mirror. Even it is greater than a plane mirror also. Suppose if it is plane mirror, this edge and this edge, that's all. So if it is a plane mirror, suppose even if it is a, see, plane mirror will be straight now. See, that's all. This is the edge, that's all. This is the field of view of a plane mirror comparatively. So you can observe all the three. This is the plane mirror field of view. So just a little bit, if you keep an object, we can't see that one. So now I hope you understood. You understood the concept of field of view of all the three mirrors. So field of view of plane mirror, field of view of concave mirror, field of view of convex mirror. Okay. So by this, what can you write the answer for this? Yes, both are correct only now. For observing traffic, we use convex mirror, and it has field of view very large than a convex and convex. So we can go with the first one now. So we can write the answer here is 1, option 1. So that means both A and R are correct, and R is the correct explanation of A. So then we come to the, okay, next question. See, the size of the mirror affects the nature of the image. And then small mirrors always form a virtual image. See, always forms a virtual image, it is not correct. See, both, I hope both the statement, that means assertion as well as reason, they don't have any meaning. They don't have any meaning. So that means for this we can write which option? Option 5. Okay. Look here once again. The size of the mirror affects the nature of the image. See, the size of the mirror has nothing to do with the nature of the image. Okay. Actually, if you have to decide about the nature of the image, it is depending on the configuration. That means size of the object, length of the object, distance that object is placed between the mirror or placed in front of the mirror. So these are all the factors which affect what? Nature of the image. But what it is told here? Size of the mirror. Of course, maybe sometimes a little part, but a majority, the majority reason for nature of the image is the size of the object and the distance where the object is placed in front of the mirror, but not the size of the mirror. Okay. So then coming to this one, small mirrors always form a virtual image. So there is no guarantee that small mirrors, whether it is, see here, it is not told whether concave or convex, right? So small mirrors he is saying, whether it is, we don't know whether he is mentioning regarding a plane mirror or a concave mirror or a convex mirror. Okay. So as there is a lack of information or confusion, ambiguity we say, as there is ambiguity in this statement, even we can cancel this statement also. So what I have written here, both are A and R are false. Both A and R are false. That's all. So let us come to this one. Then here, a concave mirror of focal length in air is used as a medium of refractive index. So refractive index is another new word for you. what is the actual meaning of refractive index is, it is nothing but the ratio of speed of light in a medium to another medium. Okay, right, refractive index. So refractive index means what? You will study this in your later classes or your 10th class or some Olympiad somewhere. So refractive index means, okay, it is the ratio of speed of light in vacuum to speed of light in a particular medium. So speed of light in vacuum to speed of light in a medium. Speed of light in a medium means we have discussed that day, optical medium. Okay, so that means it could be solid or liquid or glass or gas or whatever it is. Okay, that is, we call it as optical medium. Optical medium. So this is the definition. This is another new word for you. What is that? Refractive index. Refractive index is nothing but the ratio of speed of light in vacuum to speed of light in medium. Speed of light in vacuum is how much? So it is, we denote it as C, small word C by V. Okay, speed of light in vacuum, and the value of speed of light in vacuum is three into 10 or 2.98 also, or actually 2.98. So this is approximated to 2.98 is approximated to 3 actually. Understood? So this is the speed of light. No problem. Generally, wherever you go, if you see any standard books also, it is given this one only. Okay. While doing any calculation or problems, we use only 3, but not 2.98. Okay. Right. So 3 into 10 power 8 meter per second. So 3 into 10 power 8 meter per second. Suppose if you want it in kilometer, so just you reduce 3 zeros. Okay, 3 into 10 power 5 kilometer per second means 3 into 10 power 5 means how much? 3 lakh kilometer in 1 second. Okay, how much? 3 lakh kilometer in only 1 second. 1 second. So that is the speed of light in vacuum or empty space. Okay, so very enormous amount of speed, which we very difficult to imagine also. Okay, very difficult to imagine. So as it is having that much of speed, the light ray is taking only 8.5 minutes. 8.5 minutes to travel from sun to earth. So for your kind information, okay, the time taken by light ray to travel from sun to earth is 8.5 minutes, which we call it as a solar minute. We call the same thing as a solar minute. And for your information, I think you might be knowing, okay, the distance between earth and sun, average distance, of course, because earth is moving in a elliptical path. We take the average distance. The average distance between earth and sun is nearly 15 crore kilometers. So 15 crore kilometers for light ray, it is taking only 8.5 minutes to cover. So we call it a solar minute. Now here the concept of refractive index is speed of light in vacuum by speed of light in medium. So you cancel speed and speed. So refractive index will not have any unit, because here speed and speed are compared. The ratio of same quantities. Suppose relative density, okay, not covered. Okay, right. So same quantities we have in numerator as well as denominator, we get only a number. That is what is mentioned here. That is what is mentioned here. What is that? Refractive index of 2. That means in some medium, okay, the refractive, that means this ratio is given as 2. Then the focal length of the mirror in medium becomes double. So he is saying that when that concave mirror, okay, of focal length some x value in air is used as a medium of refractive index of 2, then the focal length of the mirror is becoming double. So it is there is no clear. The information is given is not sufficient. And let us see the reason. If you see the reason, the radius of curvature of the mirror is double that of focal length. Yes, this we are sure. Okay, this one it is sure. Okay, because we know that already R is equal to 2F or F is equal to r by 2. Okay. So by this, what choice or which number can we give? The radius of curvature of a mirror is double that of the focal length. See, double the focal length. Okay. So here we can come to a conclusion that what is that? Reason is correct only, but assertion we have some ambiguity. Okay, yes or no? Okay, the focal length of a radius of curvature of a mirror is double that of focal length. So option 4 we can go, I think. Option 4. A is false. Okay, option 4. Right. So this is not correct, but this is correct. Okay. So finally we have only one question, one more question regarding this. Then we'll go to the next topic. I'll rub okay, this question. Very, very important questions. So this is of little bit next level questions, ma. Okay. So I think your MSET level, IIT basic level you can think. Theory only, but important. Of course, this is theory only, but they can catch you in any manner if you are not strong at basics. If you are not strong at basics, the examiner, that means the you whatever the entrance exams you are writing, no, MSET and all, MSET, IIT, NEET, etc. So there you need to be thorough even in theory also. Okay. Now I'll write the next question. Okay. Okay. Fifth question. Question number 5. So that's fine. We can produce a real image by convex image under any circumstances. Okay, assertion. We cannot produce a real image by plane or convex mirror. A real image by plane or convex mirror. Plane or convex mirror. Plane or convex mirror under any circumstances. Okay. Under any circumstances, convex mirrors. Okay, then reason. So reason for this, what is given? The focal length of a convex mirror is always sigma. The focal length of a convex mirror is the focal length of a convex mirror is always taken as positive. Is always taken as positive. Okay, this is one question we have, and one more question. The ray incident along normal the middle of the spot in reflection. Okay, next question. I'll write it here. Next question, what we have is question number 6, that is assertion. Arrangement along normal to the mirror. Ray incident alone normal. Okay, incident alone normal to the mirror retraces its path. To the mirror retraces its path. And then reason, what is the reason given here is, let us see the reason. In reflection, angle of incidence is always equal to angle of reflection. Okay. In reflection, angle of incidence is always equal to the angle of reflection, right? Angle of reflection. So this is the statement. Okay. So these are the questions what we had. Then, okay, let us see this question first. So we cannot produce a real image by plane or convex. See, for convex mirror, actually, okay, if the object convex mirror, okay, if the object is real, image is virtual. If the object is virtual, okay, if the object is for a virtual object, okay, it will form a real image. You can get a real image. So this is the condition what you have to remember. See, for a convex mirror, if the object is virtual, the image what you get is real image. So this concept is actually not present in your 9th class syllabus, but it is in the higher classes, that means intermediate syllabus, IIT level. Okay. So that's why while discussing the bits, you may get some little more points than your general textbook. So that's why I have included these bits here, right? So this is one of the facts what you have to learn. That's all. Okay. So generally, what, suppose for a convex mirror, if the object is a real object, then its image is always virtual. And if the object is virtual, that means image you are taking. Object is virtual means what? It is one of the image formed for a real object, and that image, if you are taking as a object, then the image formed for that virtual object is real. The image formed is real. Little critical concept, but try to understand. Okay. So what is the concept? Simply, for a real object, convex mirror always gives virtual image. For a real object, convex mirror always gives virtual image. But if the object is virtual, then the image is real, which is formed by what? Which is formed by convex mirror. So you can eliminate this statement, finish. So even one example, one case we are getting also, this statement becomes wrong. So here we cannot produce a real image by plane or convex. So we are able to produce a real image with the help of a convex mirror. Then this statement is no longer correct. Okay. Then the focal length of a convex mirror is always taken as positive. So here also you have to think once again. Okay. Focal length is always taken positive. So how come just now we are explaining here? See, for virtual object, then real image is formed. Yes or no? So that means what? You are measuring this. That means in this case, the focal length will be this side only, no? So here also it is proved it is wrong. That means for convex mirror, okay, in a particular situation, what is that one? If the object is virtual, then the image is real. Hence, focal length also becomes negative. Okay, focal length also will become negative. So, what is the answer for this? We will go with the 5. Okay, option 5. So, that means both the statements are false only. Both the statements are false only. So, that is about this question. Then, coming to this one, a ray incident normal. Okay, we will take all the 3 types of mirrors. Okay, we will take normal incidence cases. So, you know very well how to draw the normal for a curved mirror. I hope so. Okay, so let us draw all the 3 cases here. So, suppose this is a plane mirror, this is a plane mirror, and this is a normal. Okay, this is the normal. So, for a ray that is incidenting along the normal, okay, there is no deviation. It will once again retraces the same path. Okay, for normal incidence, no deviation. Now, let us see this case now. So, let us see the curved mirror case now. So, concave mirror only first we will discuss. So, concave mirror normal, what is the concept here? Suppose if a ray is incidenting along the normal, that means from the normal means suppose radius of curvature. So, this is center of curvature. This is center of curvature. Normal means what? Any ray drawn or a line. Okay, a line drawn joining between center of curvature and the line joining between center of curvature and any point on the surface. This is the normal. This is the normal for curved mirror. So, what is happening here? Any ray, if a ray is incident like this, okay, so it will trace back the same path once again, okay, along the normal. It retraces the same path. Okay, suppose if a ray is coming like this, it will go like this. So, suppose if a ray is coming like this, then it will retrace the path same like this. So, here I have taken the upper part, here in the lower part. Okay, no need for confusion. Okay, I will take only one ray. So, this is the center of curvature. The line joining this, any point on the surface of the mirror and the center of curvature is the normal for this. Then, if you take the same thing, suppose if you take a even a convex mirror also. So, this is concave mirror and this is convex mirror. So, for this also what? Any line. So, for this the center of curvature is this side. So, from here to here. So, you join any point. You join any point here from here to here. Then this is the normal. This is the normal for a convex mirror. Now, any incidence, you see here. So, in reflection, angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of reflection. So, from the normal we are measuring, and this is angle of incidence and this is angle of reflection. Both are same. Even here also we can take any example. Okay. So, okay, right. So, for this normal I am drawing the incident ray. Suppose a ray is striking like this and reflecting like this. So, this is the normal angle of incidence, angle of reflection. So, here also the same thing. Okay. So, any ray hitting like this. So, this is the incident ray. This is the reflected ray. I hope you are understanding. So, this is the normal. Now, this is the angle of incidence and this is the angle of reflection. So, here also angle of incidence and this is the angle of reflection. Okay, students. So, I hope you have understood this question. So, see here, a ray incident along normal to the mirror retraces its path. See, normal incident, it goes back again. Normal incident, Okay, it will retrace the same path. Normal incidence, it retraces the same path. Okay, so I hope, and in reflection, angle of incidence, see, angle of incidence equal to angle of reflection. Angle of incidence, angle of reflection. Angle of incidence, angle of reflection. Okay, got it. Thank you for listening to the class, students. We will meet in the next class. Bye.